Okay, here we're just going to do a few more examples on raising a power to a power. So if you have something n to the fourth raised to the seventh, right? So that becomes n to the 4 times 7, which is n to the 28th. So think about it, when you have the numbers next to each other like this, the powers next to each other, you multiply, right? Unlike if you had n to the 4th times n to the 7th, which in this case you add them, 4 plus 7, so that becomes n to the 11th, right? So there are two different situations with powers. Likewise, if you have x to the 2/3 raised to the 1/2, that just becomes x to the 2/3 times 1/2, which this is just multiplying fractions, right? So you just multiply the numerators, multiply the denominators, so you get x equals, those cancel out, so you just get x to the 1/3, and that's your answer. What about if you have y cubed times y to the 5/2 raised to the -2? Well, this -2 is only being applied to this y base, right? It does not apply to this. So we do exponents first, right? So we're going to have y cubed times y to the 5/2 times 2, right? And that's like 2/1. So we get y cubed times, those cancel out, so that's just y to the 5th. And that becomes y cubed times y to the 5th, so you add the exponents, and that gives you y to the 8th. And there's our answer. So why don't you try a few? X squared times x to the 6th raised to the -4th, and w to the -2 times w to the 5/3 cubed, and s to the -5th raised to the -1/2 times s to the 3/2. Okay, so do those practice problems in your notes. Let's look at another example. If we have n to the 1/2 raised to the 10th power times 4 times n raised to the -2/3, all of that cubed. Well, let's just look at it piece by piece. This first part here, n to the 1/2 raised to the 10th power. Well, that is n to the 1/2 times 10, which is n to the 5th, right? And now our second piece here, well, this cubed is being distributed to the 4, to the m, and to the n, right? So that's going to give us 4 cubed times m cubed times n to the -2/3 times 3, right? So that's going to give us 4 cubed, which is 64, m cubed, and n to the -2/3 times 3, well, that's like 3/1, right? So those 3 simplify, which is just n to the -2. Let's just make a bit more space up there. So now we have n to the 5th times 64 m cubed n to the -2. So we're going to put 64 out front, right, our number. We can cross that out. Then m, right, because it's LMNOP. M is first in the alphabet. Cross that out. And then we have n to the 5th times n to the negative 2. And what do we do when we're multiplying the same base? What do we do with our powers? We add them, right? So we have n to the 5 plus a negative 2. So that's 64 m cubed n cubed. And there's our answer. Got it? So you just want to remember, like up on this step here, that you're distributing that cube power, the power of 3, to each part inside the parentheses. Now you try one. So this should be practice problem number 4. X to the negative 2 squared times 3xy to the 5th, all of that to the 4th power. And finally, just one quick thing about scientific notation. So you can use the property of raising a product to a power to solve problems involving scientific notation. For example, to simplify the expression 3 times 10 to the 8th squared, you raise both 3 and 10 to the 8th to the 2nd power, then multiply the 2 powers. So you get 3 squared times 10 to the 8th squared, and that gives you 9 times 10 to the 16th. So here is one last practice problem just for good measure. So what is the kinetic energy of an aircraft with a mass of 2.5 times 10 to the 5th kilograms traveling at a speed of 3 times 10 to the 2nd meters per second? So the formula for kinetic energy is 1/2 mass times velocity squared. And velocity is speed. So the kinetic energy is equal to 1/2 times the mass times velocity squared, which is the speed. Okay, so try and see if you can figure that out. All right, that's it.